Welcome! In this video, I'll introduce you to coordinates, midpoints and length of the line segment, as well as the equation of straight line. This is one of my favorite topics of them all, and you guessed it, this is the one topic you must understand if you want to pass Maths GCSE exam. Before we move on, please support this channel by clicking like, share and subscribe button so that you don't miss out on any one of my latest tutorial videos. Your support will go a long way and help others who really need this support. All graphs are drawn on a set of x and y axes, which defines the mathematical space, using the order pair of numbers x and y, known as the coordinates. They can be used to give positions on the graph. The first number tells us position along the x-axis, and the second number is position along the vertical y-axis, from the position where x and y-axis intersect. This is also known as the origin. The origin has the coordinates of 0, 0. The coordinates of 0, 2 is a position 0 units along the horizontal axis and 2 units along the positive y-axis. Similarly, 0, minus 2 is 2 units away from the origin along the negative y-axis. 4, 0 on the other hand is 4 units along the positive x-axis and there is nothing along the y-axis. Minus 2, 0 is 2 units away from the origin along the negative x-axis. Point minus 1, 3 is 1 unit along the negative x-axis and 3 units along the positive y-axis. Similarly, you can define all the other points on the graph using these two coordinate system. For example, minus 2, minus 3, 2, 2 and 6, minus 3. They all can be defined using only these two pair of numbers. The shortest point connecting two points is a straight line segment. The midpoint of the line segment is exactly halfway between the endpoints. So for example, the midpoint of the line connecting the coordinates 0, 0 and 2, 2 is exactly at 1, 1. The easiest way to find the midpoint is to add the two coordinates and divide the result by 2. For example, in order to find the midpoint of the line connecting minus 2, minus 3 and 4, 3, in this case we add the x coordinate minus 2 with 4 to give 2 and we divide by 2 to give 1. And similarly, we add the y coordinates minus 3 with 3 to give you 0 and we then divide 0 by 2 to give you 0. Hence the midpoint of this line has the coordinate 1, 0 from the origin, which is exactly 3 units along the horizontal axis and 3 units along the vertical axis from the lower end of the line. Notice that this is exactly halfway between the 2 points. In general, the midpoint of the line connecting two general points, say x1, y1 with x2, y2, can be found by adding the x and y coordinates and dividing each coordinate by 2. It is also possible to find the length of the line segment connecting 2 points using the help of Pythagoras' theorem. Suppose that line is drawn connecting 2 coordinates. A right-angled triangle can be drawn using these points. As per Pythagoras' theorem, 3 sides of the right-angled triangle are related using the equation c square equals to a square plus b square. Where c is the longest side of the triangle, this corresponds to the length of the sides connecting the 2 points, and a and b represents the length of the other 2 sides of the triangle. Now suppose that two coordinates were 1, minus 1 and 4, 3. Then the horizontal length of the triangle is given by subtracting the x coordinate 1 from 4, which is equal to 3 units. Vertical height of the triangle is given by subtracting minus 1 from 3, which is equal to 4 units. Using the Pythagoras, we can relate the length of the line connecting 2 points. If we let c be the length of the line, then the equations can be written as c square equals to 3 square plus 4 square. We can then square root both sides to give c equals to 5. This can be generalized. If x1 and y1 and x2 and y2 are connected by a straight line, then the horizontal distance a of the line is given by subtracting x1 coordinate from x2, and vertical distance b is given by subtracting y1 coordinates from y2. Hence, the formula for finding the length c can be expressed as square root of x2 minus x1 whole square plus y2 minus y1 whole square using the Pythagoras. All horizontal lines have the same equations of the form y equals to a, where a is a fixed number. For example, horizontal line passing through 2 on a y-axis has the equation y equals to 2. This passes through the coordinates minus 1, 2, 0, 2, 1, 2, 2, 2, and 3, 2, and so on. Notice that this graph always has y coordinates of 2. Similarly, the horizontal line passing through minus 3 has the equation y equal to minus 3, and this line has y coordinates of minus 3. The equation of x-axis is therefore y equal to 0, as it passes through 0 on the y-axis. All vertical lines have equations of the form x equals to a, where a is a fixed number. For example, vertical line passing through 3 on the x-axis has the equation x equal to 3. This line passes through the coordinates 3, 2, 3, 1, 3, 0, 3, minus 1, and so on. All the x coordinates are always 3. When the line passes through 2 on the x-axis, the equation is x equals to 2. Similarly, if the vertical line passes through 1, 0, minus 1, and minus 2, the equations of the line will be x equal to 1, x equal to 0, x equal to minus 1, and x equal to minus 2 respectively. Some graphs are not either vertical or horizontal. For example, consider drawing the graph of the function y equals to 2x plus 1. In order to draw this graph, we need to have table of x and y values. We need at least 2 pair of coordinates in order to draw a straight line graph. Suppose the value of the x ranges from minus 2 to 2, then y can be calculated by substituting the value of x into the function. For example, when x is 0, y is given by multiplying 2 with 0 and adding 1. Thus, this gives you y equals to 1. Similarly, when x is 1, y is 3. When x is 2, y is 5. After working out few values of y's, you may be able to recognize the pattern on y coordinates. For example, on this occasion, y values are increasing by 2. Therefore, in order to work out the values of y's when the x is minus 1, we can subtract 2 from 1, which gives us minus 1. And continuing this way, we can see that the next value of the y before minus 1 must be 2 less than minus 1, which gives us minus 3. Coordinates that the line passes through are therefore minus 2, 3, minus 1, 1, 0, 1, 1, 3, and 2, 5, and so on. This can be plotted on the graph and joined by a straight line. What you now have is the equation of a line y equals to 2x plus 1. All the plotted coordinates and the points in between that lies on the graphs are governed by the same basic principle, which is y equals to 2x plus 1. Gradient of a straight line is a measure of how steep the line is. It is calculated by dividing the vertical distance between the 2 points by the horizontal distance between those 2 points. Vertical distance is the change in y coordinates, which is given by subtracting the y coordinates. And the horizontal distance is change in x coordinate, which is given by subtracting the x coordinate of those 2 given points. If the 2 coordinates are, let's say, x1 and y1 and x2 and y2, then change in y coordinate is going to be y2 take away y1. And change in x coordinate is going to be x2 take away x1. Therefore, the formula for finding gradient can be written as y2 take away y1 divided by x2 take away x1. For example, 2 coordinates on this line are minus 1, 4 and minus 3, minus 2. We can use these coordinates to find the gradients of the line. We can first label these coordinates with the label x1 and y1 and x2 and y2. Then we can use the formula y2 take away y1 over x2 take away x1. Substitute the value of coordinates into the formula. 4 take away 2 is the same thing as 4 add 2, which gives us 6. This is the change in the y coordinates. Similarly, minus 1 take away minus 3 is the same thing as minus 1 add 3, which gives us 2. This is the change in the x coordinate. Now we divide the change in y coordinate by the change in x coordinate to give 3. So the gradient of this line is exactly 3 units. This number tells us that for every 1 unit you go along the horizontal x-axis, you gain 3 units of height along the y-axis. So the line which goes up by 6 units in the y-axis for every 1 unit in the x-axis will have the gradient of 6. Higher the gradient, steeper the line becomes. When the line is fully vertical, the gradient is infinitely large. When the gradient is a smaller value, the line is less steeper. For example, this line which goes up by 3 units along the y-axis for every 3 units along the x-axis has a gradient of 1 unit. This line is much less steeper than the line which has the gradient of 3. When the line is fully horizontal, the gradient is now 0, since the change in y coordinate is 0. The gradient also tells us which way the line will be tilting. For example, line with the gradient +3 gives the line that is slanting towards the right. Think of this as climbing uphill. On the other hand, the line with the gradient -3 will be the same size, but it will be sloping towards the left. You can think of this as going down the hill. It means for every 1 step you take along the horizontal x-axis, you will lose the height of 3 units along the vertical y-axis. Any straight line equations which has the form y equals to mx+c, where m denotes gradient of the line, c denotes the place where graph crosses the y-axis, also known as the y-intercept, and x and y are the general points on the line. The gradient are the important aspect of the straight line equation, as it tells us about the steepness and the direction of the slanting line. Line connecting any 2 points of the same straight line has the same gradient throughout. For example, this line passing through 2 on y-axis. So the y-intercept in this case will be 2. Gradient can be calculated by picking any 2 points on the graph where the line passed through. In this case, change in y coordinates is 4 and change in x coordinate is 2. Therefore, the gradient of this line is 4 divided by 2, which is equal to 2. And finally, the equation of this line can be written as y equals to 2x plus 2. It is also possible to work out the equation of the line when given a gradient and a point on the line. For example, suppose this line has a gradient of 6 and passes through point 34. We start by writing the general equation of straight line, which is y equals to mx+c. However, we are also given that the gradient is 6, so we know that the equation of the line with the gradient will be of the form y equals to 6x plus c. C is the y-intercept of the line and is also unknown, but we can use the given point to calculate this missing value. Since the line passed through the point 34, we know that when x is 3, y must be 4. So we substitute this into the equation and rearrange for c. This gives us c equals to -14. Hence the complete equation of the line is going to be y equals to 6x minus 14. We can also work out the equations of a straight line when given 2 specific points on the line. We can use the 2 points to work out the gradient as well as the y-intercept. For example, take a look at this line connecting the point 1, 1 and 2, 3. In step 1 of the calculation, we start by calculating the gradient of the line using the gradient formula. So we level the points x1 and y1 and x2 and y2. We then substitute this into the gradient formula. Calculating this will give us gradient of 2. In step 2, we want to start by writing the general equation of a straight line and substitute the gradient we calculated earlier. Now we need to substitute one of the given coordinates to find the y-intercept c. On this occasion, we choose the coordinate 1, 1 and substitute this into formula, which gives us c equals to -1. We can now finally rewrite the equation in full. So the equation of a straight line will be y equals to 2x minus 1. Thanks for watching. Be sure to try the exercises to test your knowledge. I'll see you in the next part.